moving on to multi-leader replication. Now, multi-leader essentially says that you have more than one leader. So then you are essentially allowing even the writes to happen on more than one nodes, right? That's a very plain and simple definition of it. So writes are allowed to happen on the multiple node concurrently with either synchronous or asynchronous communication between the leaders. And this is an important point. So now let's say there are two leaders, right? So your first call can go to one leader, and now this leader has three replicas. Similarly, there is another leader, leader L2, that also has three replicas, right? Now I'm calling this leader writing something, I'm calling this leader again writing something. And this leader also, both these leaders needs to talk to each other. And that can happen in a sync way and async way again. Yeah, right? Now just think about this scenario, right? If it happens in a sync way, that means if you are writing on one leader, you'll have to wait till the point this data is copied to the second leader and also acknowledges success. Then you send an acknowledgement as success to the client. But uh, if it's an asynchronous replication, then you can write on either of them, and one can say it's success, and the other one still does not know about it. It will have to catch up, just like a replica in a leaderless scenario, in a leader based replication, right? Now the second approach, which is asynchronous replication in case of leader, there could be a problem of conflict resolution, right? So let's say there is a key K, and then in a concurrent way, right? I have written a value as value 1 to this replica, this leader, and then value 2 to this leader, right? Now what happens? How do you reconcile these two values, right? It's a conflict scenario. I mean, I will just pause here and like all of you to think on this and give any input here. And whatever the use cases also which you have seen in your real life based on this.
Yeah, I agree with your problem statement that you mentioned. This synchronized, synchronization is a problem there.
So
so does it mean that this master or active, it should be used in certain cases only, where the write which we are doing in different DBs, they're mostly independent of each other? Then
No,
you
no,
will not have to.
yeah, agree. This could be a scenario, but let's not assume that, because we
because
generally
that's a
have,
solved case.
yeah.
Yeah, I mean
That's a
that
solved
will be
problem.
like
Yes.
easier case where you can use master, right?
The conflict is
No, so
happening
in
when
that
you are
case
writing on the
it
same
will
case.
become master slave, right? Because your another set of master slave is independent of the master slave, other master slave, right? So it is like single master slave replication on each side.
That will become sharding with replication, right, Brijesh?
Yeah.
Your other data sets keys are, one of the keys are on this, half of the keys are on this. So in that case, for half of the keys, it's always one leader only. So it becomes a master slave from that point of view.
So I have example for this because my company uses this. I don't know why. They might have other solutions for it. So yeah, since they are the financial services and only the RDBMSs are used. So how they are using is like a similar case, active nodes, active master, and it's like data is in async way replicated between the both masters. So you could say that your data is not up to date, right? But at one point of time, all your traffic is on a single server only. Although they call it active, don't know why, but they're serving all the traffic from single master slave data center. I think this is just for the failover thing that they might have using. So what they're doing is, in case of failover, like one data center failover, which like it naturally never happened, but they do it while testing or releasing. When they do the releases, what they do is like when they are releasing the new code, they but for that duration they redirect all their traffic to the other data center. But since you're saying that your data is not up to date for the other one, they keep it as read only for that duration. You are not going to do any write action there. Means you could only use your website in read only mode. And once your the current data center is back, once you're done with the releases, or in any case, maybe let's that data center was failed or some failover happened. Generally, it also happens. I think I've seen some emails also, some that site is in read only mode because the data center is down or something happened. I think I've seen the power failure sometimes. There was an email about. So, but the solution for this is like the other one, when they are redirecting the traffic, that is always in read only mode. So there is no way that you could say that like obviously the data is outdated, but once this current since they have blocked all the writes there, they have kept it in read only. Once their original data center or setup is back, they will again migrate all this traffic and enable the right thing. So that's how
But
they are using.
so this is active active or active passive, Brijesh?
Well, at a point of time, both are active, just because in case failover happened,
Hmm.
the traffic will be redirected. But not in a case that serving some traffic from here and serving some traffic from here. At
So
one
okay.
instance,
So
all the traffic is served from
essentially a
one data center.
disaster. This is a disaster
Yeah,
thing,
essentially
right?
a
DR.
disaster recovery.
It's a DR cluster. Another is a DR
Yeah,
cluster, right?
DR cluster. Yeah.
Hmm.
I think that could be the only way you could rely on these type of setups.
Hmm.
Otherwise, you always have the challenge that you mentioned about the master.
Hmm.
You don't want to lose your data. So
So very simple example, which was I was mentioning earlier, is your calendar, right? So let's say you're offline and you're not connected to the internet, and then you're editing a Google Calendar on your or let's say your office thing, right? Let's not go to talk about the Google case. Now you might have booked a particular room, right? When you have when you have booked a particular room, this you will get a success response that okay, this particular room is booked for you at let's say 3 to 4 for tomorrow. Now what happens is when you come online and you try to sync this data with the server, you realize that there is another person who has booked the same room in exactly the same time slot, right? So this is a scenario where you are a leader because you have a local copy of the database, and it's giving you a success response. It's not waiting to sync the data with the remote and then give you a success. I'm specifically saying that okay, that's a necessity here. That is giving you success that your room is booked. Now the other guy also, he got a success that room for him is also booked. Now when it's try to reconcile, there is a conflict. So how do you resolve this conflict, right? So this is a multi-leader scenario, and this is an asynchronous replication case. So, okay, had it been a synchronous replication, right? Then when before giving me a success, it would have also tried to send the data to the other server leader or whatever other database, and there it would have realized okay, nobody has still booked that room, so it would have given me a success. So then for sure it's a success for me, right? But if it is guaranteeing me a success without uh, in an asynchronous way, then there would be a conflict which has to be resolved later on, right? And how do you resolve that conflict? I mean, there could be different conflict resolution algorithm, and the final output that okay, who gets the room, either I get the room or the other guy gets the room, will depend on what kind of conflict resolution solution that we have applied. But this is a problem which will come with asynchronous replication in case of multi-leader replication. Yeah, so
then
Brijesh,
previous one.
another example I can give is Google Docs, right? Google Docs allows you to, let's say I and you are both working on a same doc, right? We're editing something. Now, uh, and so the conflict will come only, and okay, what is the mode of replication? Mode of replication is asynchronous here, right? Uh, yeah, because it will not always connect to your copy to see whether particular because conflict is there or not, right? It will
Yeah.
allow me to write it. only I think only what I've seen is it when you are offline, it does not allow you to edit for sure, right? Because then it's not even able to connect any even in a short window of time, right? So it does not allow you to edit. But if you are online, then it allows you to edit. But when I'm typing, it does not stop me. That okay, let me check at this particular line and this particular word point at that particular line whether the other guy he has changed something or not, right? It does not at a particular instant of time. It does not do it. It does not sync that. So in this case, it's a leader with an asynchronous replication. Your copy and my copy, both this being the two different databases.
Okay.
Now, what will happen is what actually happens is as long as I'm editing different lines, no issues. As long as I'm editing different character index, if I can say that okay, that one line is an array, and I'm at a particular index, and I'm not the conflict is not at a particular index, it's still okay, right? But if the conflict is at particular index of the same line, then there is a conflict resolution has to be applied to resolve that conflict.
I think that's the important algorithm, the conflict resolution one. How you are probably deciding who wins the.
Yeah, yeah. So okay, so I think concurrent document editing is one example. Calendar example I gave. One active passive for this disaster recovery. And why that would be a leader again is you don't want to lose the data. If you don't keep leader, just a replica if you keep outside, then you might lose the active transaction, right? Which because of the replication lag, right? So these are some of the benefits, but still, then how do you resolve the conflict? So let's say if I say, just wanted to touch upon the other aspect of it. If I say that I want to maintain an active, uh, sorry, I want to do a sync based in case of let's say the Google Docs, right? So that means if there is one document and 10 people are editing it, then I will have to make sure that my document gets copied to all the 10, then only I get success. So that means while typing, I will get stuck a lot, right? I just type one key and then it updates the 10 different copies, maybe, who might be actively editing it. And then only I'm able to type the next character. So not a good user experience. So that's the reason they might not have chosen sync-based replication there.
Right.
So one point that okay, this is very important application of it in Google Docs system design that we can apply of a multi-leader. I mean, you get the thought process how to think about this. But because I never thought of, I even asked this question in few of the interviews, in one of the interviews, but I have never thought that okay, this is an example of a multi-leader application.
So yeah,
Yeah.
I
Google
actually have
Docs
never.
uses, yeah,
Yeah,
go ahead.
please go ahead, Kath.
So Google Docs uses something called operational transformation actually. So
Hmm.
in order to resolve this if two users are actually trying to, so what they do essentially is every user keeps a copy of um, of whatever was the last document version that he was seeing, he or she was seeing. Okay, and
Hmm.
every user keeps that copy, but it gets synced. So essentially what happens is writes from two different users will be going to both their copies, like how many, like whatever the number of users are there, right? It will be writes will keep going to all the users, but it does not ensure that you'll be reading the correct copy. I mean, at a specific time, like you can actually sync whatever change. Say me and Brajesh are actually trying to edit the same document, right? Then our rights, it's important that our rights get persisted, but it's not important that we read the accurate copy at the current time. We can sync it at a later point, like once you resolve the conflict. So that is essentially operational transformation. I don't think it happens at the database level, it happens at the application level layer itself. But I mean, yeah, we can use it um,
Hmm.
as an example for multiple masters also.
Yeah, so that was actually my question. Like, I have never read about it, like how Google Doc does it. So you answered the question. So conflict resolution, that I think that it happens automatically, right? Does it? I've never seen prompting it to me that hey, somebody has edited, overwritten you. No, right?
No, 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 never. It never does that. It resolves it automatically. I've shared one article which I had read long back. So
Okay.
that is the algorithm behind conflict resolution for Google Docs.
So Karthik, one question there. So maybe it is applying one of the solutions, right? Which is the next point,
Yeah,
which is the last right wins, right?
right,
So basically, what is the late last right based on, I can do a time stamping, right? Again, you can
correct.
question, okay, how do you do stamping in case of, I mean, distributed system? But if I do time stamping, then I'll say, okay, what is the last timestamp? That right wins. But what if the timestamps are also synchronized? I mean, exactly same. Then
No,
how would it resolve?
I think for multiple masters, we have to sync times between two servers. I think that is an exercise, but yeah, we can go into. I'm not really sure, but I mean, an easy way to resolve this is like, say if two different users are there, right, and we have two different masters or leaders. So whatever read operation goes to that particular reader, right, or to that particular leader, first the write operations will happen if it is impacting the same document. So it has a log of all the transactions essentially. Like for example, I have a document A, right, and two different leaders are there. Both need to keep copy of A. So if somebody is trying to read from A, then it will first check whether there is a write operation which needs to happen on A. Then it will perform that write operation first, and then only the read operation will happen.
Okay.
So in that way, we can always ensure that read from that particular from any of the masters is actually returning us the correct like whatever is the eventual consistent state, that is what is being returned in the read query.
So you're saying I think you described OCC only, right here, right? Optimistic concurrency control.
I am not sure what it is called. I mean, I don't remember the
Okay.
term, but yeah.
Okay.
See, I just missed the last discussion due to network. Could you please repeat it how you were solving this problem with last rights win?
Sure. Yeah, Shivam, sure. So say we have a document called A, or we have a record in our database, A record, line number or record number A, and then two different masters are there, and somebody is trying to read the same record A. So both the masters will actually have first look up whether whether there are any pending operations, pending write operations on that record A. They will perform that write operation first, and then the read operation will be fulfilled. So say you wrote to replica 1, right, which is master 1, and then master 2 got a copy of that this record has changed from master 1. But when you try to read the same record, your request went to master 2, right? So master 2 will actually first write that whatever instruction he got from master 1, and then respond to your query of reading that record.
So it's a type of a synchronous replication.
Only if you are trying to read which a record which is pending an update. If it is not pending any update, it can actually look it up very quickly, right? I mean, it has a list of operations which is pending. If you are trying to read the same record, then it is synchronous. Otherwise, it is asynchronous.
Okay, so it is something like the optimistic concurrency control.
Yeah,
Okay.
like I said, I don't know that.
I
Yeah, I
also
don't
thought
know.
Karthik is describing that only. Yeah.
Same thought process.
Same response from the Kunal, and then
But we two didn't hear each other, so it was
yeah,
asynchronous.
it was just like going back in time.
Yeah. ठीक है. So let's move on.
I think
Shivam, you want to? Yeah.
one solution could be if we can make read and write as a different columns, and then replicate the data by one master would be of the read quorum, and then one master could be of the write quorum. That could be one solution. I'm not sure.
Nahin, so you will have the same problem, na? Ultimately, when you are trying to resolve between those two, acha, you said one for read, one for write.
Yeah,
Nahin, but then in that case, you'll always have to send the write to the server, right? Before you allow the user to go ahead for each character that he's typing, right?
correct.
So that is latency issue, right?
Yeah, the latency issue will come. Correct.
Can you talk about this conflict resolution data types as the other solution? As Karthik mentioned,
So,
operational transformation. This is the second approach to that.
so if I speak about the CRDTs, let's say it's very vividly right now in my mind. It like if I share what I read a long time back from the Reacts paper, they consist of something called as sets, and sets has two things. One is the add an element, and then there was a delete an element. So what it was doing was like something serializing the operations, and then maintaining the version vectors for the object. And whenever there is an operation going on to this particular data type of a particular key side, which is like the optimistic way, then it used to serialize those all the operations which are coming to it. And now, since it is being executed on a single master, so it was easy to maintain that. But while it's working on the multi-master, the response was quite. I mean, because there is a replication required in the both of them, so latency was quite high. And then there was some operation costing that is involved, because whenever you are improving something, uh, you have to read the complete set, whether the data transformation is completed there or not, and then the complexity goes high. Thus, the uh, how I say, the latencies was increasing. So that was the side effects of these CRDTs also. So that's why they started doing some state management of the CRDTs, and thus the concept of state management replication. I'm not sure currently about that concept, how it is implemented in the other side. So state management replication is also one concept of the I mean that we used to do we used to follow in the replication.